We talked about being able to write it out as a 0, 90, 180, 270, and back to 360. You need to be able to do that in radians as well. So make sure this is second nature to you, starting at 0, pi over 2, and we can think of it as just increasing by pi over 2's. So 1 pi over 2, 2 pi over 2, which the pi's or the 2's cancel out, and we're left with just pi. 3 pi over 2, which we can't break down. And then 4 pi over 2 brings us back, and that is the same as 2 pi. So having those in our heads, and then the 45, or the halfways between those, would be our pi over 2 divided by 2, or pi over 4. Pi over 4, the same as 45 degrees. All right, so let's draw in our pi over 6. And we know that pi over 6 is between 0 and pi over 2. And in fact, it's a little less than pi over 4. So we can draw our arm right there and mark it in as pi over 6. And there we go. All right, let's head into the second part of this. All right, so what we can do here is we can just say, what is a coterminal angle? And again, coterminal angles, infinite number of possibilities for this one. So we'll just pick one example. And let's go negative for our example. And so if we went around there, we could figure that out. One way you could do it is you could say, 3 pi over 2 and then add a little bit kind of idea. Another way to do it is you could say 2 pi, in other words, all the way around back to 0, minus our pi over 6, so minus that little bit that we started from. So that's a way to do it, and we are wanting to make common denominators, so 12 pi over 6 minus pi over 6 is equal to 11 pi over 6. And because we were heading in the negative direction, let's make sure that we show this, our coterminal angle, as that. And in fact, it'd be even more accurate if we wrote it like that, and then to show that we were going negative 2 pi, and then we added the pi over 6. And that's perfectly consistent, so it's a better solution that way. All right, let's go to the general solution. And here we go, our theta, and pi over 6. And so coterminal angles, what are all the different ways that we can get back to that same place? So if we started at pi over 6 and we said we looped around a full circle and back to pi over 6, we would be saying 2 pi and back to pi over 6, same place. So indeed coterminal. But then we could do it again. And so we could say plus 4 pi if we want. And we've done 2 loops and back to the same place, or 6 pi. And so we can keep looping it like that. And so why don't we just put an n there and say it could be, n could be 1, 2, 3, and so on. But we could also head in the negative direction. So we'll put a minus there. And so we could have gone negative 2 pi or negative 4 pi or negative 6 pi. And in fact, our first example, if we just did negative 2 pi, is our example coterminal angle that we provided there, the negative 11 pi over 6. But there we go. We would say that n is an element of the whole number group. And I will point out that if we were to say n was just an integer, then we could just show that as a positive, and it would have been accurate as well. And the negatives just take care of themselves. But this is a great way to show your solution. We're done.